Look down at your feet right now. Whatever you are wearing on the soles of your shoes, rubber, synthetic foam, compressed plastic, is one of the most effective electrical insulators ever engineered by human hands. You bought it for comfort, for grip, for style. You had no idea you were buying a barrier, a wall between your body and a planetary scale energy source that has been sitting directly beneath your feet your entire life. Here is what nobody tells you. Your heart does not beat on chemistry alone. Your brain does not think on sugar alone. Every signal your nervous system has ever fired, every muscle fiber that has ever contracted, every thought you have ever had, all of it runs on moving electrical charge. You're not a biological machine with a few electrical components. You're an electrical machine assembled from chemistry, running entirely on voltage. Right now, as you read this, somewhere between 1,500 and 2,000 violent thunderstorms are erupting simultaneously across the tropics. Lightning is striking the ground roughly 100 times every single second. Each strike drives a massive surge of negative electrical charge deep into the surface of the Earth. Across geological time, this process has been running continuously, and the result is that the ground beneath your feet carries a vast permanent reservoir of free electrons, negatively charged particles with nowhere to go, sitting just beneath the surface, pressing outward. The planet is a battery, not as a metaphor, as a measurable physical fact. Now walk into a forest, not a park, a forest, where trees have been rooted for decades, pressing root systems meters deep into mineral-rich, moisture-laden soil. Something happens the moment you step off the pavement. Your rubber soles are still on your feet, so nothing crosses yet. But when you reach out and press your palm against bark, or when you take off your shoes and stand barefoot on the forest floor, AA closes. The planetary charge finds a path, and that path is you. What crosses that gap is not symbolic. It is not spiritual. It is not a metaphor borrowed from ancient wisdom. It is electrons, real, measurable, countable particles streaming along an electrical gradient from a region of high charge density into a region of lower charge, from the Earth into your body. And the moment that transfer begins, something inside your bloodstreams starts to change in ways that have now been measured in peer-reviewed laboratory studies. This video is going to take you from the soles of your shoes to the surface of a single red blood cell. We are going to trace the exact physical path that a planetary electrical charge travels from a lightning strike in the Congo Basin to the inside of your cardiovascular system when you wrap your hand around the bark of an oak tree. We are going to look at what happens to your blood when it runs low on electrical charge, and what happens the moment that charge is restored. And by the end of it, you will never look at a tree the same way again, because what you thought was a plant is actually a vertical wire rooted into the largest electrical conductor on Earth, stretching upward through water and living tissue, waiting for something low voltage to touch it. That something is you. Start with the most ordinary moment of your day. You wake up. Your alarm goes off. Before you have opened your eyes, before a single conscious thought has formed, your heart has beaten several times. Not because you asked it to, not because a chemical signal told a mechanical pump to squeeze. Your heart beats because a cluster of cells in your right atrium spontaneously generates an electrical impulse, sends it racing down a precisely mapped network of conductive tissue, and triggers a coordinated wave of muscular contraction that moves roughly 70 milliliters of blood with each cycle. That is not biology borrowing from physics. That is physics, pure and fundamental and measurable on any ECG in any hospital on Earth. Your nervous system works the same way. Every thought you're forming right now is a cascade of charged sodium and potassium ions crossing cell membranes in sequence, each one triggering the next. A signal moving at speeds approaching 120 meters per second along your longest nerve fibers. Lift your arm. That is an electrical command dispatched from your motor cortex and received at a muscle fiber faster than you can consciously register it. Blink, electrical. Feel pain, electrical. Every sensory experience you have ever had, from the taste of food to the warmth of sunlight on your skin, has been converted into an electrical signal before your brain was allowed to interpret it as anything at all. Strip away the biology, and what you are left with is a remarkably sophisticated electrical system, one that generates measurable electromagnetic fields, runs on voltage gradients across cell membranes, and communicates entirely through the controlled flow of charged particles. The question is not whether your body runs on electricity. The question is where that electricity comes from and whether we have been cutting ourselves off from the most abundant source of it on Earth. Scale your view outward. Pull back from your body, past the room you are sitting in, past the city, past the continent until you are looking at the planet from above. Right now, at this exact moment, there are roughly 2,000 active thunderstorms erupting simultaneously across the tropical band of the Earth. Each one is a massive atmospheric engine pulling warm, humid air upward, separating electrical charges across kilometers of cloud, and eventually discharging that separation as lightning. Each lightning bolt delivers an enormous pulse of negative charge, electrons, directly into the Earth's surface. And this is not an occasional event. It is happening constantly, around the clock, every day of every year, and it has been happening for billions of years. The result is that the surface of the Earth carries a permanent, stable, net negative electrical charge. The ground beneath your feet is not electrically neutral. It is saturated with free electrons, unattached, mobile, negatively charged particles pressing outward with a surface charge density that physicists have measured and mapped in detail since the early 20th century. This is called the global atmospheric electrical circuit, and it is one of the most consequential physical systems on the planet. The ionosphere, the electrically conductive upper layer of the atmosphere, carries a net positive charge. The surface of the Earth carries a net negative charge. Between them, separated by roughly 60 kilometers of resistive air, a constant voltage difference of around 300,000 volts is maintained. The lightning storms are the generators, continuously replenishing the charge that slowly leaks away through the atmosphere. The whole thing is a circuit, a slow, vast, planetary circuit that has been running without interruption since before the first living organism appeared, and every living thing that evolved on this planet evolved inside it, touching it, embedded in it, biologically shaped by it across hundreds of millions of years. Every living thing that is, except modern humans, who invented rubber soles. A tree has no such problem. A tree has never been insulated from anything. Look at a tree differently for a moment. Not as a plant, not as a carbon sink, or a source of timber, or a piece of scenery. Look at it as an electrical structure. A mature tree pushes its root system outward and downward through soil that is moist, mineral-rich, and electrically conductive. Those roots make direct physical contact with the ground over an area that can extend far beyond the tree's canopy, sometimes across hundreds of square meters of continuous contact with the negatively charged earth. The root system is not just anchoring the tree and pulling up water. It is, electrically speaking, a massive buried electrode. From the roots, the electrical continuity runs upward through the tree's cambium layer, the thin band of living tissue directly beneath the bark, which is saturated with conductive fluid. Water is a conductor. Water carrying dissolved minerals and ions is a very good conductor. The cambium layer of a living tree is essentially a cylinder of conductive biological material, running from the electrodes buried in the planetary battery all the way up to the outermost layer of bark that you can press your hand against. The tree is not a plant with some electrical properties. It is an electrical conductor that happens to be alive, rooted into the largest supply of free electrons on Earth, extending the supply upward into the open air where another electrical system, you, might come close enough to connect. And when you do connect, the physics is not complicated. Electricity, at its most fundamental level, follows a gradient. Electrons move from regions of high electron density toward regions of lower electron density, from high electrical potential toward lower potential. The Earth's surface has a high density of free electrons. Your body, living its insulated modern life, has a deficit. When your bare skin makes contact with bark, or when your feet touch forest floor, that gradient closes. Electrons flow, not because of intention, not because of belief, because of the same physical law that makes current flow from a battery terminal the moment you close a circuit. The Earth is one terminal. You are the other. The tree is the wire. The rate of transfer is not violent. This is not a shock. The voltages involved are small and the current is slow, but the direction of flow is not ambiguous, and the duration matters. Stand against a tree for 10 minutes with bare skin contact, and electrons have been migrating into your body that entire time. Walk barefoot through a forest for an hour, and you have spent 60 minutes as the low-voltage end of a planet-scale circuit. The question, the genuinely strange and consequential question, is what those electrons actually do once they are inside you. And to answer that, you need to zoom in further than the forest, further than the tree, further than your skin, all the way down to something invisible to the naked eye, flowing through roughly 100,000 kilometers of blood vessels inside your body right now. Inside your bloodstream, the story gets stranger and more consequential. Your blood contains approximately 25 trillion red blood cells, a number so large it resists comprehension. Each one is a biconcave disc, roughly 8 micrometers across, flexible enough to fold itself through capillaries narrower than its own diameter. Their job is to carry oxygen from your lungs to every tissue in your body and return carbon dioxide on the way back. That much you probably know. What almost nobody teaches is that each red blood cell carries an electrical charge on its outer surface. A negative charge distributed across the cell membrane, generated by the arrangement of molecules that make up that membrane's outer layer. This charge has a name, zeta potential, and it is not incidental to how blood behaves. It is the governing principle of blood flow. Here is why it matters. Like charges repel, two negatively charged objects push away from each other. A fact so basic it sits in the first chapter of any physics textbook. Your red blood cells, each carrying a net negative surface charge, are subject to this same rule. They repel each other constantly. That repulsion is what keeps them separated and individually suspended as they move through your vessels. It is what keeps them from clumping. When zeta potential is high, when each cell carries a strong negative charge, the repulsive force between cells is strong. The cells remain well separated and blood flows with low viscosity. Think of it as a river of evenly spaced particles, each one maintaining its own lane, the whole system moving with minimal friction. When zeta potential drops, when cells lose that surface charge, the repulsive force weakens. Cells begin drifting toward each other. They aggregate, they clump. The river starts to thicken. Viscosity rises. The heart works harder to push the same volume through the same vessels. Flow through small capillaries becomes sluggish or stops altogether. This is not a hypothetical risk. It is a measurable, observable physical process that happens inside every human body in real time, responding to real conditions. And one of those conditions, as a landmark 2013 study would demonstrate, is whether or not your body is carrying enough electrons. The charge on the surface of your red blood cells is not fixed. It responds to the electrical environment of the body as a whole. And the electrical environment of the body as a whole are response directly and measurably to whether you are plugged into the earth or insulated from it. Think about what it actually looks like when those red blood cells lose their charge. Picture 25 trillion particles suspended in a moving fluid, each one ordinarily held at a distance from its neighbors by an invisible wall of electrostatic repulsion. Now, imagine that wall weakening, not collapsing all at once, just softening. The repulsive force between cells drops a fraction, and the gap between them narrows a fraction. And because there are trillions of them making this adjustment simultaneously, the cumulative effect on the fluid as a whole is dramatic. Cells that were individually suspended begin to drift into loose clusters. Clusters attract more cells. The fluid that was once a fast-flowing river of evenly distributed particles starts to thicken. What was thin enough to thread through a capillary 8 micrometers wide becomes sluggish, reluctant, sticky at the margins. This is not a metaphor for inflammation. This is inflammation, or more precisely, it is one of the mechanisms that drives it. Thick aggregated blood moves poorly through small vessels. Oxygen delivery to peripheral tissue slows. Cellular waste removal slows. The body registers the impaired flow as a low-grade physiological threat and mounts a response accordingly, releasing inflammatory signals, elevating baseline stress hormones, maintaining a state of heightened sympathetic arousal, not because there is a pathogen present, not because of injury, because the charge on the surface of 25 trillion cells has drifted in the wrong direction, and the entire cardiovascular system is paying the mechanical cost of that drift. The most consequential question in the whole story is the one nobody thought to ask. Can you reverse that drift from the outside? In 2013, a research team published what remains one of the more quietly radical papers in cardiovascular biophysics. Their question was straightforward. Does grounding the human body, creating direct electrical contact between a person and the earth, produce measurable changes in blood viscosity? To answer it, they used a technique called dark field microscopy, which allows you to observe living red blood cells in real time, suspended in plasma, without staining or fixing them. They took blood samples from subjects before grounding, connected those subjects to a grounded electrode, the same electrical potential as the Earth's surface, for 40 minutes, and then took blood samples again. What they saw in the post-grounding samples was unambiguous. The red blood cells had separated, the clumping had reversed, the aggregates that were visible in the pre-grounding samples had dispersed into individually suspended cells moving freely through the plasma. They measured the zeta potential directly and found it had increased. The negative surface charge on the cell membranes had strengthened, the electrostatic repulsion between cells had intensified, and the blood had thinned accordingly. 40 minutes. That is how long it took to produce a statistically significant, microscopically visible change in how 25 trillion cells were behaving inside a living human body using nothing but a wire connected to the ground outside. No pharmaceutical compound, no dietary intervention, no procedure of any kind, just electrons moving along a gradient from the Earth into a person whose body needed them. The researchers calculated the reduction in blood viscosity and noted that it was clinically significant, the kind of reduction that, if achieved with a blood-thinning medication, would be considered a meaningful therapeutic outcome. They were not describing a wellness trend. They were describing basic electrochemistry applied to the most consequential fluid in the human body. But the blood is not the only system responding. While those red blood cells were rearranging themselves, something else was happening further up the chain in the branch of the nervous system that controls your baseline physiological state without asking your permission. Your autonomic nervous system has two settings. One of them is slowly killing you. The other one turns on when your feet touch the ground. The sympathetic branch of your autonomic nervous system is your emergency response architecture. It raises your heart rate, constricts your peripheral blood vessels, suppresses your digestion, sharpens your focus onto immediate threats, and floods your bloodstream with adrenaline and noradrenaline, the catecholamine hormones that prepare your body to fight or flee. This is a brilliant system when you are facing an actual physical threat. It is a catastrophic system to live in chronically. And the uncomfortable reality of modern life is that most people in industrialized societies are running a persistent low-grade version of sympathetic activation for reasons that have nothing to do with physical danger. Insomnia, financial stress, sensory overload, social pressure, and one reason that has been almost entirely overlooked, chronic electrical disconnection from the Earth and the state of physiological dysregulation. That disconnection quietly sustains. Multiple grounding studies have measured what happens to adrenaline and noradrenaline concentrations in urine when subjects are returned to electrical contact with the Earth. Urinary catecholamine levels are a reliable proxy for sustained sympathetic nervous system activation. The body excretes these hormones as it clears them, and elevated levels in urine indicate the body has been producing them in elevated quantities over a sustained period. Across multiple trials, subjects who are grounded for extended periods showed significant reductions in urinary adrenaline and noradrenaline compared to controls who were not grounded. The parasympathetic branch, the rest and digest system, the physiological counterweight to fight or flight, began to reassert itself. Heart rate variability, a sensitive marker of autonomic balance, shifted in the direction associated with health and recovery. The nervous system, given a stable electrical footing, began to stand down from a threat posture it had been maintaining in many cases for years. The peace you feel in a forest is real, but it is not coming from where you thought it was. It is not the scenery. It is not the silence. It is not even the phytoncides released by the trees, though those compounds are doing their own documented work on your immune system through an entirely separate mechanism. The calm is electrochemical. It is a nervous system releasing its grip because the electrical environment of the body has been stabilized by something the body was designed across hundreds of millions of years of evolution to stay in constant contact with. And when you reach out and touch a tree in that forest, you're not touching one tree, you're touching all of them. Beneath the forest floor, invisible and almost incomprehensibly vast, is a network that makes the internet look modest in scale. The mycorrhizal network, the web of fungal filaments that infiltrates the soil of virtually every forest on Earth, connects the root systems of individual trees to each other across areas that can span entire ecosystems. A single teaspoon of healthy forest soil contains kilometers of fungal hyphae, microscopic threads thinner than a human hair that extend in every direction, linking root to root, tree to tree, species to species in a continuous subterranean web. This network transfers carbon, nitrogen, water, and chemical signals between organisms. It allows a dying tree to redistribute its resources to neighboring saplings. It is how a forest thinks, slowly, collectively, without a central node, in a structure that mathematicians describe as scale-free, meaning it has no central hub and no fixed boundary. It simply extends organically for as far as the forest extends. This network is also conductive. The hyphae are embedded in moist mineral soil. They are in continuous contact with a negatively charged earth, and they connect, through the root systems they infiltrate, to every tree in the forest, including the one you have your hand pressed against. When you make contact with bark and electrons begin flowing from the earth into your body, you are not drawing from a single local source. You are tapping into an electrical grid that extends across the entire forest floor in every direction, continuously replenished by the planetary charge moving through the soil. The tree is not the battery, the tree is the socket. The battery is everything beneath it, connected to everything beside it, stretching in all directions to the horizon. Your ancestors knew forests as home. They slept on the ground. They walked barefoot. They worked with their hands in soil. They were never, in the course of an ordinary day, electrically disconnected from the earth for more than a few minutes. The disconnection is not ancient. It is shockingly recent, a consequence of rubber-soled shoes, paved surfaces, and elevated buildings that arrived in evolutionary terms in the last heartbeat of human history. The chronic physiological consequences of that disconnection, thicker blood, dysregulated nervous systems, elevated baseline inflammation, are things we have been treating as independent medical problems, reaching for pharmaceutical solutions to symptoms whose common upstream cause we have not thought to examine. The intervention is not complicated. The science says it does not need to be. Find a forest, not a park with manicured grass and paved paths. A real forest, where trees have been rooted for decades, and the floor is covered in leaf litter and living soil. Take off your shoes. Let the soles of your feet make contact with the ground. Find a tree whose bark feels rough, reel under your palm, and leave your hand there. Not as a ritual, not as a spiritual practice, though there is nothing wrong with it being both, as a deliberate, informed act of electrical maintenance, the same category of decision as drinking water when you are dehydrated or sleeping when you are exhausted. Your body has a charge deficit that has been accumulating since the day you first started wearing insulating shoes on insulating floors in insulating buildings. The Earth has a surplus that has been accumulating since the first lightning bolt struck the ground 3 billion years ago. The physics of what happens when those two things make contact is not mystical. It is not alternative. It is the same electrochemistry that governs every other charged system in the known universe. You are an electrical machine. The Earth is the grid. The forest, rooted into that grid across thousands of square kilometers of conductive mycorrhizal soil, is the charging station. Walk into it. Touch something. Stand still long enough to let the gradient close. Your red blood cells will begin to separate. Your cortisol will begin to drop. Your nervous system will begin slowly and measurably to exhale. Not because the forest is magic, because the physics was always there, waiting for you to stop insulating yourself from it.